For 30,000 years, humans gazed at stars through dynasties, yet still don't know universe's real bound. What blocks our sight and traps our minds? And why still can't we calculate the universe's size? Today, I'll use simple words to explore the universe's big questions. Do we really understand it? This is a solar system-centered universe model, showing all we can currently observe. Diameter, 93 billion light-years. Inside holds about 2 trillion galaxies, beyond clear stars and galaxies. The outer tentacle-like edge is the universe's large-scale cosmic web. It's like fine filaments connecting all the galaxies in the universe. However, what this image shows is only all the matter that can be observed from Earth and space telescopes, not the entire universe. Beyond the observable universe, all is silent, unknown. Its light can't ever reach Earth within any human lifetime here. Far from Earth, the universe expands even faster than light itself there. No cosmic expansion means space itself expands, not objects just moving through a fixed space. So the observable universe likely spans only a tiny patch of space. It may be bigger than you think.
Why is the universe expanding?
Big Bang Theory and known physics say the universe has been expanding ever since it first began. Because gravity links all matter. It works like a brake. So the universe's expansion should slow down slightly. But in 1998, a bizarre astronomical event made scientists sweat. Type Ia supernovae billions of light years away from Earth were actually dimmer than expected. Scientists infer universe has sped up, not slowed, for billions of years. Like tossing an apple skyward. It doesn't fall, it speeds up, as if driven by an unseen force. This discovery forced scientists to admit the existence of a dominant and unknown mysterious repulsive force in the universe, which is dark energy. But dark energy itself is a mystery. We don't know what it is, only that it makes up 68% of the total mass energy of the universe and has a repulsive effect.
Will the universe expand forever? If it does, what consequences will that lead to?
Very likely, and ever faster. If dark energy stays steady, the universe will accelerate expansion forever, roughly tens of billions of years from now. The observable universe will shrink. Galaxies will slip beyond sight. The Milky Way will merge with nearby Andromeda, and aside from that, everything turns dark. No galaxies visible. If the universe keeps expanding, it will lead to disasters. Galaxies vanish, clusters rip apart, stars wink out one by one. This fate is called heat death. Universe expands. Matter grows ever more diffuse. As stars fade, even black holes evaporate from Hawking radiation, leaving a uniform, icy cosmos with near-zero energy density. Time will eventually lose its meaning because there will be no more changes to mark its passage.
You say the universe is expanding, so does that mean it has a center?
There's no true center. The Big Bang didn't burst from one spot in space. Space itself began expanding everywhere, all at once. Like ants on a balloon, as it expands, each sees others move away, but none is at the center. Our universe is like that balloon's surface, just in higher dimensions. So neither you, me, Earth, nor the Milky Way is the universe's center. From where you stand, the universe seems to expand around you. That's the heart of the cosmological principle. At large scales, universe is uniform, isotropic.
Why did the universe to 13.8 billion years ago this time have a start?
The Big Bang marks time's beginning for us. Before it, time may have meant nothing, since time and space come as one. Space-time? The Big Bang began space-time itself.
What was there before the Big Bang?
This question is as meaningless as asking what's north of the North Pole. Or perhaps the answer itself is completely beyond our comprehension. Some theories, like cyclic and multiverse models, try to avoid the beginning question, yet have no evidence.
If so, our universe may not be the only one. Could others exist too?
Scientists aren't sure if they exist, but the multiverse often appears in physics. For example, inflation theory. During inflation, Some regions stop expanding, forming bubble universes. Maybe we're just one bubble. Plus string theory and the quantum multiverse idea. Although these are still just mathematical possibilities with no observational evidence, many scientists believe they exist. These theories explain time travel paradoxes clearly, like the famous grandfather paradox too.
The concept of time travel you mentioned, can we achieve it?
General relativity says rotating black holes, wormholes, and cosmic strings may allow closed time-like curves, time loops. But they're fragile theories, needing negative energy or exotic matter to hold. And we've never found these substances in nature, nor made them in any lab. But even if time travel works mathematically, chronology protection may forbid it. Because the universe blocks time paradoxes, like the grandfather paradox, and demands energy for time travel.
Since a black hole could be a wormhole to another universe, what's inside a black hole?
Before the first black hole photo was captured, no one knew its look. Surely it was never a hole. Current theories show that a black hole is like a region of space-time where gravity is so strong that not even light can escape. At its core, relativity predicts a singularity. Infinite density, curvature, strangely, at the singularity. General relativity and quantum mechanics clash there. Hence, we require a more final theory, like quantum gravity, to explain what truly occurred there. As quantum gravity tries to unify general relativity, another odd phenomenon appears. At the Planck scale, spacetime is quantum and jittery, not smooth or continuous. Singularities may give way to quantum foam or blurred strings, defying general relativity. Quantum mechanics says the world is discrete and probabilistic. General relativity says spacetime is continuous and certain. At black hole and Big Bang singularities, both theories break down together. String theory and loop quantum gravity seek unity, but experiments are near impossible. We await deeper revolution in physics to rethink spacetime and matter.
How could our world be a probability wave? If that's the case, could we be living in a virtual world?
It can't be proved or disproved. Elon Musk said our odds of living in the world are under 1 in a billion. Professor Chen Ning Yang publicly said a creator likely exists in this world here, but it's not human-shaped. If advanced civilizations can build universe-scale simulators and simulations vastly outnumber reality, then the odds for any of us being real are tiny. More a philosophical guess. There's no scientific test at all. Like a game NPC, how could it prove to itself its world is real or fake?
Can humans make a world or a universe?
Theoretically, a tiny chance. Some quantum theories suggest that extreme energies, like inside black holes or high-energy lab collisions, could trigger new inflation and create a baby universe. But these ideas stay in equations. Even if real, we can't see or steer them. Brain-computer interfaces top headlines. If someday scientists use a brain-computer interface to plant a false memory and program your mind, controlling what you sense and how you act. In that case, how would you distinguish whether the beautiful memories you perceive and have experienced are real?
If virtual worlds don't exist, why haven't we found aliens in such a vast universe?
Simple answer. Either life is rare, or civilizations last only briefly in the universe. Though the Milky Way is old and vast, Earth took billions of years to develop technology. If other civilizations last only hundreds of thousands of years, our chances of meeting are nearly zero. Most scientists believe alien life exists. We just haven't found it yet. In our Milky Way, over 100 billion stars exist, and each has at least one planet too. Kepler telescope data shows Earth-sized planets are common in the Milky Way. Yet life doesn't mean civilization, and certainly doesn't mean we can reach it at all. Over cosmic time, alien civilizations may rise and fall in different eras, missing each other by billions. No solid alien signal may mean civilizations are rare in the universe. Or, if they exist, the dark forest rule keeps them silent and avoids contact. Or we're searching the wrong way.
If aliens exist, could they have invented faster than light spaceships?
It's just absolutely impossible. Special relativity says no object with mass can ever outrun light itself. And speed isn't the true barrier, it's the limit of cause and effect. Mass needs infinite energy to reach light speed. Even the whole universe as fuel can't break that limit. Massless particles like photons move at light speed. Exceeding light speed means effects come before causes, reversing time and breaking causality.
Why can time only move forward and not backward?
This may relate to entropy. The second law says entropy in an isolated system always rises, moving from order to disorder and giving time its direction. In the universe, a vast isolated system, entropy only rises. What we call time moving forward is entropy evolving from low to high. If time ran backward, entropy would drop on its own. But real life, an untended house gets messier, and melted ice can't return. Entropy only rises irreversibly. Relativity allows time travel in theory, but going back still faces huge challenges. Why was the universe's initial entropy so low? Some think it's due to multiverse selection, or maybe time reverses at a singularity, breaking causality.
What is the shape of the universe?
Based on measurements, the universe is nearly flat, like endless paper, with zero curvature. The universe follows Euclidean geometry on large scales. Yet some theories say the universe resembles a sphere or saddle in 4D space, its curvature too tiny to detect.
Why is there more matter than antimatter in the universe?
This is also one of the great mysteries in physics. The Bang 13.8 billion ago should have made equal matter and antimatter. When they meet, they become light. But now universe is mostly matter. This means some early mechanism broke the symmetry, leaving one extra matter particle per billion pairs. And those few survivors make up the universe, and us.
Is the void truly empty?
What you think is empty is actually full of quantum fluctuations, where virtual particles and antiparticles constantly appear and vanish, borrowing and returning energy in an instant. Casimir effect experiments indirectly confirm this phenomenon. The void isn't empty. Microscopically, it's a dynamic quantum state. Our universe came from quantum fluctuations. Quantum fluctuations allow something from nothing, but why these laws exist is beyond human grasp. We can only accept them as given.
Can quantum entanglement beat light speed for information?
No. Entangled particles share states instantly, but can't transmit messages, since the link is random, uncontrollable. When you measure an entangled particle, outcomes are random. You can't control it to encode bits like 0 or 1. Distant particles respond instantly, but you get only random noise. Messages still need light speed or slower links. So entanglement is mere synchronicity, not an FTL info tunnel.
The universe is complex. Why study it at all then?
We study the universe not just to find a pre-written ultimate answer, but to complete a self-awakening for our civilization. Freed from borders and planets, humanity looks to all things origin and end. That perspective is meaning. Bound by light, speed, we can't touch what lies beyond the observable universe. Yet that very mystery fuels advances in human science and philosophy. Where do we come from? Where are we going? And why do we exist in this universe? Perhaps these questions have long been deeply imprinted on our souls. Every particle in our bodies has witnessed endless ages across countless times and spaces. Iron in our blood came from dust flung deep space by 2 neutron star crashes. Trace copper in us saw a white dwarf die. Even our plainest bone was forged in a far nebula, billions of light years away. All beings share our fear of death, and share one cosmic bloodline with us as well. In a way, our stir when we gaze at the night skies enchants. It's homesickness etched in elements, since all of us are star-born too. Monogataripedia here. Thanks for watching and thinking.